Let's look at a quick overview of Key Management Server. This presentation on Google Slides is available at the following URL, tinyurl.com/kmsvault. In this presentation, we will look at what a Key Management Server does, what does it help with, some nice aspects of this implementation of a Key Management Server. We will also look at a quick overview of the moving parts, the tech stack that is used in this implementation, as well as a demo. So what does a KMS solve? There are lots of security keys used for a variety of purposes within organizations. Some keys are used to protect data at rest, sometimes data in transit. Sometimes keys are used for establishing handshakes and establishing other keys. Keys are also used for signatures and also enforcing non-repudiation. And these form the cornerstone of all data security initiatives. So what does it solve? If every application or app ecosystem uses a different approach for key generation, distribution, storage, usage, backup recovery, then it increases the complexity of key management. If every application was to do it in its own way, then that increases the risk also. A centralized key management server simplifies and makes key management transparent. And once a key management server is in place, users and applications can just request keys and just use the keys for whatever purpose without worrying about the management of the keys. So KMS can help with tracking keys as the number of keys grows. Once a key management server is in place, it enables data security within the entire organization or application ecosystem. Data can be secured and it can be shared, and that information is stored in metadata. It also lowers administration and performance costs. So what does this implementation of KMS do? Users and applications can ask for keys and it will generate keys for the users or applications. It will give it to the users over REST APIs or it will serve it over REST APIs. It will store the metadata for the keys and the data along with storage and integrity. And that is done as part of key management, transparent to the users and applications. So what are some nice implementation details or some interesting features of KMS implementation? When a user requests a key to protect data with, that key is called a data key. On this implementation of KMS, every data key is protected by a different key encryption key. The data key is not stored in the open. It is protected by another key, which is a key encryption key. Both the data key and the key encryption keys, the algorithms used for each of these, there are two standard algorithms used on the platform. One is AES 256-bit and the other is Camellia 256-bit. And the algorithms used for KEK and DEK protection, they are chosen in random. So a KEK is a key encryption key, a DEK is a data encryption key. There is an optional user interface that we will see in the demo for managing keys and data and sharing the data. There is a user interface to also encrypt data or messages from users, and it is only limited by the size. There is an underlying security library that is written, and that is FIPS compliant. Another nice aspect of this implementation of KMS is that it spreads the data protection, or it spreads or scales the security with key encryption keys and data encryption keys. So every data point is protected by a separate data key or a DEK, and that data key is protected by a separate key encryption key or a KEK. And that key encryption key is generated using slots and also a random or a salt. So what is the advantage of spreading it out or scaling out the keks and decks for every data point? The advantage is that it reduces the radius of a key compromise. If a kek or a deck or a data point is leaked or exposed, it does not affect the other data points. It also introduces high cost hurdles. An attacker has to overcome multiple keys to access all the data. So what is the advantage there? It grants time to respond and protect versus the time that is available with a single master key. The third advantage is that we can have group operations and granular key rotation, revocation, and key operations. We have already seen data isolation. It simplifies administration. Admins and users do not know about keks and decks being handled, and it's handled transparently by the server. Users will still own their own keys and data that they generate, and they will still control who that data is shared with. A quick overall architecture looks like this. Minimum overall internals. The database holds keys and metadata of the keys. It also holds the secured data, the encrypted data, along with its metadata. There is the API, the KMS API, which apps and users can use to do the operations, including data sharing. There is also a monitoring aspect of the application, and this helps with ops monitoring. We will have a look at the dashboard for ops monitoring when we look at the demo. So what is the tech stack that is used for this implementation? The entire stack is containerized on Docker. The front end is written in JavaScript and JavaScript libraries. React front end, Redux for state management, Bootstrap for CSS, and there is also custom CSS. Vite for application configuration and build. The application configuration is done using Vite for React applications. The backend is written in Python, Django REST framework for REST APIs. The database is Postgres, and asynchronous operations are done using Celery and RabbitMQ. The regular suspects for a Python Django backend. The observability part of the software is done using FluentBit, Elasticsearch, Sentry, Grafana dashboards, and there is also Kibana for following up on logs. The transparent part of the security implementation is done or provided using Python packages. There are two Python packages. One is Wavda Security Utilities. This is a simplified API on top of Python cryptography and all the implementation of encryption, decryption for the keys, key generation, authentication, HMAC authentication. The underlying API is written and is stored in this particular Python package. There is a second package, Django HMAC authentication. This provides server-to-server optional authentication using HMACs. And this library or Python package in turn uses the first package, which is Wavda Security Utilities. The HMAC authentication package is provided as optional, and React applications, users, and programs can interact with the server and authenticate with the server using Jout authentication. This HMAC authentication library is provided as an optional authentication mechanism. Both these Python packages are built separately. The CI/CD is separate and it is maintained on GitLab Community Edition. Let's have a look at the application. Let's log into the server. So the key management server homepage. Let's create a key group for storing our keys for the presentation. We have to give an alias or a user-friendly name for the key group. We can give it a description. Let's create the key group. So we have that key group. We can go into the details of it. We can see that it has got a name, it has got a description, and the key group is active, and we can perform group operations on the keys that are added to this key group. A key group is a logical aggregation of keys used for a particular purpose. So let's go ahead and add some data keys to that particular key group. Let's say that it is key A. An alias is a user-friendly name for a data key or any key. It is one that is used to search for a key from a huge list of keys. Let's give it a comment or a description. Every key is added to a key group, and let's go ahead and create that key in that key group, and it has been created with that alias and the comments. Let's go back to the keys list, and we can see that the key has been created in that particular key group, and the algorithm that is used to protect the data key is AES 256. So the KEK is separate from this key. The KEK uses AES 256 to protect this particular key. We can see that the key is active, and let's go ahead and encrypt some data with this key. It is a random message or data point that the user can have to protect to share with, let's say, other users, or to just hold on the platform. Let's give it an alias. So this is a data point that will be protected using this particular key, and we can go and have a look at that key on that ID. So let's encrypt the data, and the data has been secured. Let's go to data vault, and we can see that this particular data point has been created, and this data point is protected by Camellia 256, and it is protected by a particular key, and it is protected by this particular key, and that key is protected by a key encryption key using AES 256. And this choice of algorithm, as we saw in the presentation, is random. We can also see that the data is not shared with anyone. If we were to go back to the data vault, we can see that it doesn't have the user's icon, which is used for denoting shared data. It is still private, and it can be shared with users. So let's first go ahead and unlock the data, and we can see that it is the demo data point for the presentation. Let's share the data point with the staff user, one of the users for the demo. If we were to go back to data vault, we can see that the metadata has already been stored on the server, and that information that the data point is shared is indicated by the icon. And we can see that there are multiple data points in the data vault belonging to multiple users. Let's log out and then log in as the staff user and see the shared data. If we were to go into data vault, we can see that there is the presentation data. It is created by the admin. And if we were to go in, the operations that we can perform is not available because this user is just a read user. This user gets to see the data. If we were to unlock the data, we can see that it's the demo data point for the presentation. So that's the KMS implementation. Let's look at the Grafana dashboard. There is a dashboard that is used for observability. We can see quick statuses on HTTP methods that are running on the API. We can also see the ingress methods. We can also see inside individual Django applications within. So we have the messaging application, the admin application, accounts. We also have the key management server application. So whatever is going on inside the platform across different applications is shown on the dashboard. We can also see within KMS what are the individual activities that are happening. Like for example, in the past 5 minutes, we were operating on the KMS application. We were encrypting data, decrypting the data. We were generating symmetric keys, key group operations. All that shows up here on the dashboard. So that's KMS, Key Management Server, a quick overview and a demo. Thank you.